Today, we are going to discuss BPMN, or Business Process Model and Notation. To start, let us begin with an overview of BPMN. The Business Process Model and Notation, BPMN, specification provides a graphical notation for specifying business processes in a business process diagram. Its goal is to support business process modeling by providing a standard notation that is comprehensible to business users while also representing complex process semantics for technical users. BPMN is a standard graphical system used to map out business workflows, featuring core components such as flow objects, connecting objects, and swim lanes. These components help bridge the gap between business analysis and technical execution. Managed by the Object Management Group, OMG, BPMN provides a universal visual language that can be understood by different stakeholders across an organization. The importance of business process model and notation, BPMN, can be understood through several key benefits. First, BPMN standardizes business process diagrams by providing a common notation that organizations can use to represent their processes. In addition, it improves communication between business and technical teams because everyone can use the same visual language to understand a process. Furthermore, BPMN makes workflows easier to understand, analyze, and evaluate, allowing organizations to identify inefficiencies and bottlenecks within their processes. As a result, businesses can make better decisions and implement improvements to make their operations more efficient. Moreover, BPMN supports process improvement and optimization by providing a clear view of how activities are performed. It also helps organizations document and standardize their business operations, ensuring that processes are consistently followed. Another important benefit is that BPMN facilitates automation and system implementation because clearly defined processes can be more easily translated into technical requirements. At the same time, it enhances collaboration among stakeholders by giving everyone a clear understanding of their roles and responsibilities. Finally, BPMN helps reduce errors through clear process visualization and can be useful for training, compliance, and process documentation. Overall, BPMN provides organizations with a clear and standardized way to understand, communicate, improve, and manage their business processes. Reasons BPMN is used during requirements analysis. Business Process Model and Notation, BPMN, is used during the requirements analysis phase of the software development lifecycle, SDLC, because it helps analysts understand, document, and communicate business processes. In particular, BPMN allows analysts to clearly represent how a business process currently works and identify what the new software system needs to support. Furthermore, BPMN acts as a bridge between business stakeholders and software developers by converting business activities, decisions, business rules, and information flows into a clear visual model. As a result, both business and technical teams can develop a shared understanding of the process, making it easier to identify requirements, clarify expectations, and reduce misunderstandings. Overall, BPMN is valuable during requirements analysis because it provides a standard and visual way to analyze business processes and translate them into clear software requirements. To continue, let us understand more about BPMN and how it is used during the requirements analysis process. There are several important reasons why BPMN is valuable to analysts when studying and designing business processes. 1. Understand current business processes as its process. First, BPMN helps analysts visualize how an organization currently performs its activities and processes before developing or improving a system. By creating an as-is process model, analysts can clearly see the existing workflow, including the tasks, decisions, people involved, and flow of information. In this way, they can better understand how the business currently operates. 2. Identify system requirements. Next, BPMN helps analysts identify system requirements by examining process flows, tasks, decisions, and data. Through this analysis, they can determine what functions and features the software needs to provide. Therefore, BPMN helps ensure that the proposed system addresses the actual needs of the business. 3. Improve communication with stakeholders. Furthermore, BPMN improves communication among stakeholders because it uses standardized symbols and diagrams that are relatively easy to understand. As a result, business users, analysts, and developers can refer to the same process model and develop a common understanding of how the process works. 4. Identify problems and inefficiencies. In addition, BPMN helps analysts identify problems and inefficiencies within existing processes. By visually examining the workflow, they can discover delays, unnecessary steps, duplicated work, and bottlenecks. Consequently, organizations can determine which areas need improvement and where changes can make the process more efficient. 5. Define future system processes to be process. Finally, BPMN can be used to design the future or to be process. After analyzing the current process and identifying its problems, analysts can create an improved workflow that shows how the new software system should operate. In this way, the to-be process provides a clear picture of the desired future workflow and helps guide the development of a new system. Overall, BPMN helps analysts move from understanding the current process, as is, to designing the future process to be. It therefore plays an important role in identifying requirements, improving communication, and ensuring that the new system supports the organization's business needs. To continue, let's look at the next reasons why BPMN is used during requirements analysis. These focus more on defining user responsibilities, system functions, business rules, data requirements, and supporting the development of the system. 6. Define user roles and responsibilities. First, BPMN helps define user roles and responsibilities within a business process. Pools and lanes can show who is responsible for performing each activity. As a result, analysts can determine the different user roles, permissions, and levels of system access that may be required. 7. Identify functional requirements. Next, BPMN helps analysts identify functional requirements by examining the activities performed within a process. These activities can be translated into specific system functions or features. For example, activities such as submit order, approve payment, and generate report may become functions that the software needs to provide. 8. Identify business rules. Furthermore, BPMN helps identify business rules by using gateways to represent decisions and conditions within a process. For example, a gateway may determine whether a payment is approved or rejected based on certain conditions. Therefore, these decisions can be translated into business logic and rules that the software must follow. 9. Identify data requirements. In addition, BPMN helps analysts identify data requirements through the use of data objects. These show the information that is created, received, updated, stored, or processed during a business process. By analyzing these data flows, analysts can determine what information the system needs to manage. 10. Support system design and development. Finally, BPMN supports system design and development by providing developers with a clear understanding of the required business workflow. Before coding begins, developers can use the BPMN model as a reference to understand how activities, decisions, users, and data should interact within the system. Let us proceed to the symbols and components of BPMN. Observe the following symbols for each BPMN component, such as flow objects, connecting objects, gateways, swim lanes, and artifacts. Please familiarize yourself with these symbols and understand their meanings, as they are essential for creating and interpreting BPMN diagrams. Events tell us what happens, activities tell us what work is performed, and gateways determine how the process flows based on decisions or conditions. 1. Event. First, an event represents something that happens during a business process. Events can start, interrupt, or end a process. For example, an event may represent the start of an order, the receipt of a message, or the completion of a process. 2. Activity. Next, an activity represents a task or piece of work that must be performed within the business process. It describes an action that needs to be completed, such as submit order, review application, or generate report. 3. Gateway. Finally, a gateway controls the flow of a process by making decisions, splitting paths, or merging paths. For example, a gateway can determine whether an order is approved or rejected, allowing the process to follow different paths based on the result. Let's now discuss the specific components of BPMN, starting with the types of BPMN events. Please observe the symbols carefully and understand their meaning and behavior. Using Microsoft Visio, you can create BPMN symbols that are aligned with the behavior and purpose of each event. Types of BPMN events. 1. Start event, single thin circle. First, the start event marks the beginning of a business process. It indicates where the process starts and identifies the event or condition that triggers the process. In BPMN, it is represented by a single thin circle. 2. Intermediate event, double circle. Next, the intermediate event represents something that occurs during the process, after the process is started but before it ends. It may represent events such as a timer, message, or error. The intermediate event is represented by a double circle. 3. End event, thick circle. Finally, the end event marks the completion or termination of a business process. It indicates that the process has reached its final point and can no longer continue along that particular path. In BPMN, it is represented by a circle with a thick border. The following example demonstrates the different types of BPMN events. Please observe the symbols carefully and understand how each event is used within a business process. Pay attention to the differences between the start event, intermediate event, and end event, as well as their roles in controlling the flow of the process. The next BPMN component is activity. Please observe the symbols carefully and understand how each type of activity is represented in a BPMN diagram. Activity. An activity represents a unit of work performed by a person or a system within a business process. Activities describe the actions that need to be completed for the process to move forward. 1. Task. First, a task represents one simple activity or unit of work. It is used when the activity does not need to be broken down into smaller steps. For example, submit application or approve request can be represented as tasks. 2. Subprocess. Next, a subprocess represents a collection of related tasks grouped together as one process. It is useful when a particular activity contains several steps that need to be performed but can be represented as a single activity in the main process diagram. A task represents a single unit of work, while a subprocess groups several related tasks into one activity. This allows BPMN diagrams to remain organized, clear, and easy to understand, especially when dealing with complex business processes. Next, let us look at an example of an activity where we can distinguish between a task and a subprocess. Please observe the symbols carefully and relate them to the descriptions we discussed earlier. As you examine the examples, remember that a task or process name should generally follow the verb plus object format. For example, submit application, review request, approve payment, or generate report. This naming convention clearly describes what action is being performed and what the action is performed on. Please also pay attention to the difference between a task, which represents a single unit of work, and a subprocess, which contains multiple related activities grouped into one process. Let us proceed to the next BPMN component, which is the gateway. The symbol for a gateway is a diamond. However, simply using a diamond without clearly identifying the condition or decision can lead to confusion about which path should be followed. Therefore, it is important to understand the different types of gateway symbols and when to use each one. Types of BPMN gateways. 1. Exclusive gateway, XOR. First, the exclusive gateway, XOR, is used when only one path can be selected based on a condition. The process evaluates the conditions, and only one outgoing path is followed. For example, if a loan application is evaluated, the process may follow either approved or rejected, but not both. 2. Parallel gateway, AND. Next, the parallel gateway, AND, is used when all outgoing paths must be executed. The process splits into multiple paths, and all of these paths are performed in parallel. For example, after an order is confirmed, the system may prepare the invoice and update the inventory at the same time. 3. Inclusive gateway, or. Furthermore, the inclusive gateway, or, is used when one or more paths may be selected depending on the conditions. Multiple paths can be followed at the same time if their respective conditions are true. For example, depending on an order, the process may require shipping, insurance, or special packaging. If more than one condition is satisfied, multiple paths can be executed. 4. Complex gateway. Finally, the complex gateway is used for custom or advanced decision logic that cannot be easily handled by the standard XOR and OR gateways. It is appropriate when the process requires more complicated rules to determine which path should be followed. In summary, the type of gateway determines how the process makes decisions and controls its flow. The XOR gateway selects one path. The AND gateway executes all paths. The OR gateway selects one or more paths based on conditions, and the complex gateway handles more advanced decision logic. The following example demonstrates an exclusive gateway, XOR. As we discussed, an XOR gateway is used when only one path can be followed based on a condition. In this example, after the user enters the PIN, the system evaluates whether the PIN is correct. If the PIN is correct, the process continues to the next transaction. Otherwise, if the PIN is incorrect, the process follows the other path and ends. This demonstrates the main purpose of an XOR gateway. Only one of the available paths can be selected based on the condition. Next, let us discuss the parallel gateway AND. The parallel gateway AND is used when all outgoing paths must be executed. Unlike the XOR gateway, which selects only one path, the AND gateway allows multiple paths to be performed simultaneously. Based on the given example, after receiving the order, the process reaches the parallel gateway. From there, all activities are executed, such as checking inventory, preparing the order, and arranging delivery. These activities can be performed at the same time because all of them are required before the order can proceed. After all the activities are completed, the process reaches another parallel gateway, which synchronizes the different paths. Once all required conditions are satisfied, the process can continue to the next step, such as shipping the product. This example demonstrates that the AND gateway requires all outgoing paths to be completed before the process can continue. Next, let us discuss the inclusive gateway, OR, which is used when one or more paths may be selected depending on the conditions. Unlike the XOR gateway, where only one path can be followed, the OR gateway allows multiple paths to be followed at the same time if their conditions are true. Based on the given example, after the triage request activity, the process evaluates the customer's request to determine what action or actions are needed. For example, if the product is defective, the process may proceed to replace product. If the customer requests a refund, the process may proceed to process refund. If there is a service issue, the process may proceed to contact support. Depending on the evaluation, one or more of these paths can be selected. For example, a request may require both a product replacement and support assistance. After the selected activities are completed, the different paths converge at another inclusive gateway. Once the required paths have been completed, the process continues to the next activity, which is request resolved. This example demonstrates the main purpose of an OR gateway. One or more paths can be followed, depending on which conditions are satisfied. And finally, we have the complex gateway, which is used for custom or advanced decision rules. It is appropriate when the decision logic is too complicated to be handled easily by the standard XOR and OR gateways. Based on the given example, the process involves a complex loan evaluation. After evaluating the different loan conditions, the system may need to consider several factors and apply specific decision rules before determining what should happen next. In this situation, a simple XOR and or gateway may not be sufficient to represent the required decision logic. The complex gateway allows the process to use custom decision rules to determine the appropriate path. Depending on the result of the evaluation, the process may end, continue to another activity, or trigger an intermediate event or another event within the process. In summary, the The complex gateway is used when a business process requires advanced or customized decision logic that cannot be clearly represented using the standard XOR and or gateways. The next BPMN component is swim lanes. Let us begin by identifying the types of BPMN swim lanes. Swim lanes are used to organize activities in a process and clearly show who is responsible for performing each activity. Types of BPMN swim lanes. 1. Pool. First, a pool represents a participant, organization, or business entity involved in the business process. It represents the entire organization or participant and can contain one or more lanes. For example, a pool could represent a bank, hospital, company, or customer participating in a business process. 2. Lane. Next, a lane divides a pool into specific roles, departments, or individuals. It shows who is responsible for performing each activity within the organization. For example, within a company pool, lanes could represent the sales department, finance department, and customer service department. Each activity is placed in the appropriate lane based on who is responsible for performing it. In summary, a pool represents the entire participant or organization, while a lane represents a specific role, department, or person within that participant. Together, pools and lanes make it easier to understand who performs each activity in a BPMN process. The next BPMN component is connecting objects. These objects are used to show the relationships and connections between different elements in a BPMN process. They help us understand how activities, events, gateways, messages, and supporting information are related to one another. Types of BPMN connecting objects. 1. Sequence flow. First, the sequence flow shows the order in which activities, events, and gateways are performed within the same process. It uses a solid line with an arrowhead to indicate the direction of the process. For example, after submit order, the sequence flow may proceed to review order, followed by approve order. This allows us to clearly see the order in which the activities are performed. 2. Message flow. Next, the message flow represents communication or the exchange of messages between different participants or pools. It is used when one participant needs to send information or a message to another participant. For example, a customer may send an order request to a company. The message flow shows the communication between these two participants. It is important to remember that a message flow cannot be used to connect elements within the same pool. It is specifically used to represent communication between different pools or participants. 3. Association. Finally, an association is used to link artifacts, such as data objects or text annotations, to flow objects such as activities, events, or gateways. It provides additional information or documentation about a process element. For example, a data object, such as an order form, can be associated with a submit order activity to indicate that the activity uses or produces that information. Unlike sequence flow and message flow, an association does not control or affect the process flow. Instead, it provides additional information that helps users understand and document the process. In summary, the sequence flow shows the order of activities within a process. The message flow shows communication between different participants, and the association connects supporting information or documentation to process elements. Here is an example demonstrating the use of BPMN connecting object symbols. Please focus carefully on the symbols shown in the example and observe how each one is used. Pay particular attention to the differences between the sequence flow, message flow, and association symbols. Understanding these symbols is important because each one has a specific purpose and meaning in a BPMN diagram. BPMN artifacts, symbols, names, and meanings. 1. Data object. First, a data object represents data or documents that are used, created, or updated during a business process. It helps show what information is required or produced by a particular activity. For example, an order form may be used when a customer submits an order, or an invoice may be created after an order is processed. 2. Group. Next, A group is used to organize related process elements within a BPMN diagram. It can be used to highlight or categorize activities that are related to one another. Importantly, a group is used mainly for documentation and organization and does not affect the actual process flow or execution. 3. Text annotation. Finally, a text annotation provides additional notes, explanations, or comments that help clarify a particular part of the business process. For example, an annotation might explain a special instruction, business rule, or important condition associated with an activity. However, like a group, a text annotation does not affect the execution or flow of the process. In summary, BPMN artifacts provide additional context to a process diagram. A data object represents information or documents. A group organizes related elements, and a text annotation provides additional explanations or notes. Things to consider when creating large BPMN models. When a business process is complex, medium-sized, or large and cannot be represented clearly on a single BPMN page, it is important to divide the process into smaller modules using subprocesses or separate BPMN diagrams. By doing this, the model becomes easier to read, understand, maintain, and update. Let us now discuss the important things to consider when creating large BPMN models. 1. Use subprocesses. First, use subprocesses to break a large process into smaller and more logical sections. Each subprocess can contain detailed activities while keeping the main BPMN diagram simple and organized. 2. Create multiple BPMN diagrams. Next, consider creating multiple BPMN diagrams when the process contains several major business functions. For example, an organization may create separate diagrams for order processing, payment, and delivery. This approach prevents one diagram from becoming too complicated. 3. Define process boundaries. Furthermore, clearly define the boundaries of each process. Identify where a process starts, ends, and interacts with other processes. As a result, users can easily understand the scope of each BPMN diagram. 4. Use proper naming conventions. In addition, use clear and descriptive names for processes, tasks, events, and gateways. For example, instead of using a vague task name, such as check, use validate customer order. Remember that task names should generally follow the verb plus object format. 5. Avoid overcrowding. Another important consideration is to avoid overcrowding the diagram. Do not place too many symbols, connections, and activities on a single page, because this can make the BPMN model difficult to read and understand. When necessary, move detailed activities into a subprocess or a separate diagram. 6. Use pools and lanes properly. Moreover, use pools and lanes correctly to identify participants and responsibilities. Pools should represent different organizations or participants, while lanes should represent departments, roles, or individuals within a participant. 7. Maintain consistent flow. It is also important to maintain a consistent process flow. Make sure that sequence flows, message flows, and associations are connected correctly and used according to their intended purpose. This helps prevent confusion when users follow the process from one activity to another. 8. Document data and rules. Furthermore, use data objects and text annotations to provide additional information about documents, inputs, outputs, and business rules. This additional documentation helps users understand the information and rules associated with different activities. 9. Use hierarchical modeling. Another useful approach is hierarchical modeling. Start with a high-level process diagram that shows the major activities, and then allow users to drill down into more detailed subprocess diagrams. In this way, complex processes can be presented at different levels of detail without overcrowding the main diagram. 10. Maintain version control. Finally, maintain version control whenever a BPMN process is updated or modified. Keep track of changes and revisions to avoid confusion between different versions of the process model. This is especially important for large organizations, where multiple people may work on or use the same BPMN models. Overall, When creating a large BPMN model, the main goal is to keep the process clear, organized, readable, and maintainable. By using sub-processes, multiple diagrams, proper naming, appropriate swim lanes, hierarchical modeling, and version control, complex business processes can be represented more effectively. BPMN can be used both before and after a system is developed, serving different purposes at each stage. Before system development, as is and to be modeling. Purpose: used in the analysis and design phase to map out existing workflows, as is, and design new or improved processes to be, that the future system needs to support. Benefit: helps stakeholders and developers understand requirements, identify bottlenecks, and specify how software features should fit into the broader business operations. 2. After system development, documentation and process mining. Purpose: used to document the final operational workflows or generated via process mining tools, which analyze event logs and system data from the newly created application to automatically map out how users are actually executing processes in the live system. Benefit: provides visibility into system usage, helps perform conformance checking, comparing the design process against actual execution, and highlights areas for further optimization. For a large or complex transaction, it is better to identify the major modules or functions first and then create a separate BPMN diagram for each module. This makes the process easier to understand, especially when putting everything into one diagram would make it too crowded. A good approach is identify the major modules/functions of the transaction. Create a BPMN diagram for each module. Give each diagram a clear figure number and descriptive name. Make sure the modules are connected logically so the overall transaction flow can still be understood. Use a high-level BPMN diagram if you need to show how all the modules connect. You can also use figure numbers and descriptive names for each module to make the diagrams easier to identify and understand. For example, you can label them as Figure 1, Order Processing, Figure 2, Payment Processing, and Figure 3, Delivery Processing. This approach makes it easier to follow the overall flow of the transaction from one module to another. Let us proceed to the other example, but this time, let us bring BPMN into the system development approach. Before that, let us clarify one thing where every diagram creator struggles: following the rules when using the symbols. You need to understand that the same platform may not support the complete set of symbols intended for your target diagram. That is why it is better to use an application that allows you to create or customize a symbol if the required symbol is not available, and then use it as part of the application intended for your project. Second, how do we bring a system development diagram into the process after development? We all know that BPMN is commonly used before system development, particularly during the requirements analysis stage. But how can elements, such as a database or a table, be inserted into a diagram? Please observe the given example and the common symbol used to represent a database. The given example shows how BPMN can be applied after the system development flow, including the representation of the database and other system components. Take a look at an example regarding the user account and access management module. The process pool is divided into 4 distinct horizontal swim lanes to represent the user and the different system roles. User represents any person attempting to access the system. Admin user role manages system-wide settings, handles database validations, and oversees administrative tasks. Client user role handles client-specific account registration and client dashboard access. Tech support role dedicated to managing and resolving support tickets. 2. Process flow and key components. Start event. The workflow initiates in the user lane with a need access event, green circle. Account status gateway. X checks whether the user is registered or not registered. Not registered. Diverts to the client user role lane, where the user can register new client account, concluding with a registration complete end event. Registered. Proceeds to the enter credentials, login task. Database interaction. Credentials are checked against the system's database artifact. Credential validation gateway, X. Invalid. loops back via display error and retry. Valid, proceeds to check the user role. 3. Role-based routing and session management. Once credentials are verified as valid, an exclusive gateway, check user role, routes the user to their respective operational lane. Admin, routes to manage system settings. Client, routes to access client dashboard. Tech support, routes to manage support tickets. All active paths eventually converge into the session monitoring and final wrap-up tasks. Monitor session activity, tracks ongoing user interactions. End event. The session concludes with a logout/session end event, red circle. Let us proceed to another module. 1. Swim lanes, participants. The process is divided into 3 distinct organizational roles to separate responsibilities. Customer initiates the purchase by placing the order. Sales department handles order verification, stock checks, payment processing, and customer notifications. Warehouse and fulfillment manages physical preparation, shipping, and sales records update. 2. Process flow and key components. Start event. The process begins with a green circle labeled Order Received in the customer pool. Activities. Tasks are represented by rounded blue rectangles, e.g., place order, review order and verify stock, process payment, prepare shipment, and ship order. Gateways, decision points. An exclusive gateway, X, checks if the item in stock. If no, the flow moves to notify the customer and cancels the order. If yes, it splits to process payment and prepare the shipment simultaneously. A parallel gateway, plus, is used to synchronize tasks before finalizing the delivery and updating sales records. Artifacts and data includes a data store icon representing payment confirmed records linked via dotted association lines. 3. End events, process completion. The diagram features 3 distinct endpoints, red bordered circles, depending on the path taken. Order canceled, reached if items are out of stock. Order delivered, reached once the order successfully reaches the customer. Process completed, reached once the warehouse and fulfillment tasks, including updating sales records, are fully finished. Next, payment processing module. 1. Structure and swim lanes. The diagram is organized into a single pool titled Payment Processing System, which contains 3 distinct horizontal swim lanes to separate organizational responsibilities. Customer initiates the purchase and completes the checkout. Payment Gateway Service handles technical validation, payment authorization, and interactions with the transaction database. Merchant System updates order records, issues the receipt, and concludes the merchant side workflow. 2. Step-by-step process flow. Start and checkout. The workflow starts in the customer lane with the order initiated event, followed by the review order and checkout task. A message connection then bridges the customer's action to the gateway service. Payment validation. The gateway performs the validate payment details task, immediately followed by an exclusive gateway, payment valid. No path. If invalid, it triggers notify customer of failure and hits a red end event, payment declined. Yes path. If valid, it proceeds to process authorization. Authorization result. Another exclusive gateway, authorization result, checks the bank's response. Decline path. Triggers handle decline, leading to the payment declined end event. Approve path. Moves forward to capture funds. Database record and fulfillment. As funds are captured, data connection lines update the transaction records database artifact. The flow then enters the merchant system lane. Completion. The merchant system executes update order status and issue receipt. 3. Final outcomes. The diagram clearly defines 2 distinct completion states. Payment successful, green circle located at the top, right in the customer lane, marking a fully completed transaction. Payment declined, red circle located under the payment gateway lane, representing failed or rejected transactions. Next, payment processing module. 1. Structure and swim lanes. The diagram is organized into a single pool titled Payment Processing System, which contains 3 distinct horizontal swim lanes to separate organizational responsibilities. Customer initiates the purchase and completes the checkout. Payment Gateway Service handles technical validation, payment authorization, and interactions with the transaction database. Merchant System updates order records, issues the receipt, and concludes the merchant side workflow. 2. Step-by-step process flow. Start and checkout. The workflow starts in the customer lane with the order-initiated event, followed by the review order and checkout task. A message connection then bridges the customer's action to the gateway service. Payment validation. The gateway performs the validate payment details task, immediately followed by an exclusive gateway, payment valid. No path. If invalid, it triggers notify customer of failure and hits a red end event, payment declined. Yes path. If valid, it proceeds to process authorization. Authorization result. Another exclusive gateway, authorization result, checks the bank's response. Decline path triggers handle decline, leading to the payment declined end event. Approve path moves forward to capture funds. Database record and fulfillment. As funds are captured, data connection lines update the transaction records database artifact. The flow then enters the merchant system lane. Completion. The merchant system executes update order status and issue receipt. 3. Final outcomes. The diagram clearly defines 2 distinct completion states. Payment successful, green circle located at the top right in the customer lane, marking a fully completed transaction. Payment declined, red circle located under the payment gateway lane, representing failed or rejected transactions. That's all for our discussion on BPMN. The PDF used in this video is available in your LMS, so you may review it whenever you need to revisit the topics discussed. If there are any topics that you did not fully understand, you may replay the video and review the corresponding sections. Take your time to study the different BPMN components, symbols, and their uses. After watching the video and reviewing the materials, please proceed to answer the graded activity. Make sure to apply what you have learned throughout the discussion when completing the activity.